All right, cool. So what we're going to be doing now is we're going to be solving literal equations, which is a big technique that's used in Algebra 1. We're going to do 4 examples. The last example is probably the most frequent one you'll see in Algebra 1, so we'll talk about that when we get there. But first, what is a literal equation? A literal equation is just an equation that's, it's got a lot of variables in it. So lots of variables. That's the basic idea. So typically, we're used to seeing like 3 equals 2x minus 2. Now down here, we've got u equals 2x minus 2. So there's just 2 variables here. You're going to solve for one of them. It's the same exact steps we've seen for solving normal equations. It's just the answers are going to look weird because they're not going to be just numbers in the normal sense. They're going to be variables, right? So for this first one we solve for x, we're going to have a u in our answer. You'll see what I mean when we get there. But the 3 steps, let's review real quick. Simplify both sides, so make sure you combine like terms and distribute. Then get your variable you're solving for to one side, and then solve using inverse operations. So the first thing I do here is I box the variable I'm solving for. So for example 1 here, we have u equals 2x minus 2. So 2 multiplied by x minus 2. So both sides of the equation are simplified because no parentheses, no like terms. The variable I'm solving for, which is x, is only on one side, so we're good for step 2 as well. So we can move to step 3. Don't worry about the u. Literally just treat this like any other equation. So we've got u is equal to 2 times x minus 2. The first thing I'm going to do is I'm going to add 2 to both sides. So negative 2 plus 2, that goes to 0. And what I'm left with is u plus 2. Those aren't like terms. So I'm literally left with just u plus 2 is equal to 2x. That's it. Then the last thing I need to do is, remember, I'm solving for x here. So this is u plus 2 equals, yes, we read this as 2x, but this right here is 2 multiplied by x. Okay, so if you're multiplying by x, what do we do to, what is the inverse operation of multiplication? Is going to be division, so we'll divide by 2 here. And then what we'll end up with is u plus 2 divided by 2 is equal to x. And this could be one possible way to write the answer. I'll talk about the second way in a second. But just notice real quick here, u plus 2 divided by 2. Notice that we still have a u here. We're not just getting like x equals 4 or just x equals some number. That's what makes a literal equation different, is you're going to have a letter, a variable, in your final answer. Okay, so this is one way they could write the answer. Another way the answer could have been written is if we divide each part by 2, so each term on the numerator by 2, we get u divided by 2 plus 2 divided by 2 is 1. And so the answer could also be written like that. So just make sure you're clear on that these 2 things are actually the same. Okay? All right, and let's keep going. So example 2, we've got y equals mx plus b, and we're solving for b. So simplified on both sides. B is only on this side, so we are good to go. This one's all letters, but don't be tripped up. We got y equals mx plus b. Well, b is pretty much already by itself. We're just adding mx to it. So what do? Is I'm going to subtract mx from both sides. So all I'm going to get is y minus mx is equal to b. It's as simple as that. All right, so next up, when we look at example 3, we got y equals mx plus b, but we're solving for x. Simplified on both sides. X is only on one side, so we're good to go. So the first move I'm going to do is subtract b from both sides. So we get y minus b is equal to m times x. And remember, this is just m multiplied by x. You can actually think about this exactly like when we had 2x here, 2 multiplied by x. This is m multiplied by x. So I'm now going to divide both sides by m. So m divided by m is 1. So I get y minus b divided by m is equal to x, or we could write this as y over m minus b over m is equal to x. So you just divide each term by m if you want to. Okay, and let's do this last one. This last one's most useful because what we're going to be doing here is we're actually going to be converting a linear equation from standard form to slope-intercept form. Now, if you don't know what that means yet, that's okay. Just know this is going to make a comeback in Algebra 1 later on. This is a very common thing that we take a linear equation from standard form to slope-intercept form. We're going to be solving for y. So what we've got is 3 times x plus 2 times y is equal to 12. I'm going to box y. There's no like terms, no just parentheses on either side. So, and all the y's are on one side, so we are good to go here. We can start solving. So I want to solve for 2 times, or just y, so I'm going to subtract 3x from both sides. So we get 2 times y is equal to 12 minus 3x. And then I'm going to divide both sides by 2. And so what we get is y is equal to 12 divided by 2. Now, for these, we're going to go ahead and just simplify each one. We get 12 divided by 2, which is 6. Minus 3 is not divisible by 2 evenly. So we get minus 3 over 2x. Now, this technically is the final answer. However, when we get to things like the star test or anything like that, we're not going to see it typically written like this. What you'll see it written as is just flipped around. So we have y equals negative 3 halves x plus 6. This is typically what we'll see. These are the same thing. They're just written in a different order. But this is going to match the slope-intercept form, which is y equals mx plus b. Okay? But don't focus on that right now. We are mainly focusing on can you solve for y. So don't worry about the standard form slope-intercept. Just know it will come back up in the future.